Oh, I wasn't ready. Oh well. Yeah. The question is, when is this lockdown called before this task is stopped or ends? How about we set just a breakpoint in here? Or I could look at the debug output, see what this is called. Or, yeah, let's use a source code. Add set index callback is not known. Notice that adds something back to, I can already see it here. Here's the callback being done, so it's being added to that, and here we run over everything, and so it's being called when that is being called, which is being called from the pipeline factory. State characteristics filled. That's being done multiple times then. Yeah, I guess. Is it true? Yeah, I guess. So this task creates tasks like other tasks already exist, but then we run them here. We start them here. It's called run, but could have called it start. And then that task calls initialize, and hence the comment. And after all characteristics are initialized, so even though these now run in, oh yeah, I changed my mind. And we run this in the low priority queue. And even though all these tasks are run in different threads from the thread pool, we just wait till all of them finished, and then we continue. Now we begin a nested for loop, a dynamic number of for loops, simply running over all the ranges that we have. And then for each value of the ranges, so I have range counters. We run those tasks again, and then we wait until all of them are filled, and then we get here. And that calls currently the doSet index hint map callbacks. But that super much looks like filling or calling initialize. So really we can just replace this whole thing here with the same construct as what we do here. Run over all characteristics, send a signal to the child task to execute that lambda, and then wait for it to be finished. then it runs from the thread pool instead of running from this thread. So this thread that executes this code here, this task, would call all these callbacks one after another, and if I replace it with this, it's going to be done in parallel. And these things compile shaders, so that's a good thing to do it in parallel. Hey, hello Dennis. Or Dennis. I would say Dennis in Dutch, but then it's written with 2 N's. Okay, yeah. Now the problem is always, what do I have to change, right? I mean, I want to make a change from queuing lambdas in a vector and then calling them one by one, to moving that code to a task and then waking up the task and then waiting for all the tasks to be finished. Now my trick usually is that I just delete what I do not want to use anymore and then I start compiling. And then you get automatically compile errors where suddenly something is missing because you deleted it. In this case, we definitely want to get rid of this function, do set index hint map callbacks. Rather, we want to get rid of this vector. This is a vector of functions that have as a argument a const reference to a set index hint map. Yeah. So I don't even really know how the code looks like that I'm going to replace this with. But I'm just going to delete this, you know, so now we're done, because it won't compile anymore until I fix it. But okay, we can be a little bit more smart, because it doesn't exist. We know that this doesn't exist, which then clearly means that this whole function has to be deleted. No more this function. Same for this one. The vector does not exist anymore, so we cannot do the callback. So this has to be removed. Okay, let's see what I removed. I removed 2 functions, which had in it set index hint map callback. Both functions have that string in it. So I have to delete that from everywhere. Grep source code. Well, I must put an X here, because otherwise we would not find one of the functions. I put the regular expressions before and after what I'm grabbing for, to make sure that we have a whole word. But if I put an X behind it, then there's no such expression. So we also find substrings from larger words. Anyway, VI. Yeah, these are the 2 test applications that I have, and here is another one that calls it. Oh, that's set point. Okay, here I'm just gonna comment it out. So we have to replace this with the with some other code. And here we have those two things. That's where we added. This lambda grabs this pointer. Well, that will be okay because we're going to run it in the same task, so that this pointer we will have. But it also captures mid-air. Can you show it so far? There's nothing to show, it's just code. I'm not writing a game, I'm writing a game engine. I have two test applications, but they basically draw triangles still, so nothing to see. Let create info, so this does not exist anymore. And the things that we are capturing here are owning window. No, that would be from the disk pointer. That one is captures. This is the argument that is being passed. The compiler was created inside the callback, which is maybe dubious if I want to compile multiple things. But since they are going to run in parallel, is that even possible? My shader compiler cannot be called in parallel multiple times? Well, I guess so. It better be. Never gave it much thought, I have to say, but well. To court, yeah, to work hard. Huh? Shade of word index. And that one is also captured. There's not really much reason to capture it. You can just do this in the lambda or in the whatever, as long as I have my window. And we have that because I need to have the owning window, and the window is just a cast. I repeat that in a different state. So let's make a new state. And let's call that state compile. And that is going to do everything inside these braces here. Still need to remember where those braces are, so I just comment it out for now. And then I'm copying it, and we move it to the new state. So the top with that here. Oh wait, the pre-processing must be done already. Yeah, cannot do that here. But I can repeat this. It should not have been changed, so there's no reason to make that class member. But these lines should not be here. So we repeat the cast and we repeat getting the vertex index and the fragment index. And then I want to call the lambda. So basically just this body here. Well, we have now all the variables. Shared input data is a member function of the current object. We have m owning windows. So you can see the m underscore means that it is a member of this class. And I made the shader frag index. We just made a compiler. But we don't have the set index hint map anymore. That was being passed as a argument here. The type is a set index hint map. Well, should be able to remember that, but let's copy this. We have to make that an class member. So let's put an M in front of it. Yeah, there's no longer lambda here. Could just delete it. Can just delete it. I think that's about it. And then we break here. Okay, let me think. So we still need to add the set index hint map. Or add it. And here we still want to do the pre-processing, which also needs the shadow vertex stuff. So yeah, it's just this part that was moved. Yeah, so basically I just moved the lambda to new the state of this task. And that won't compile because we don't have the set index hint map in this object. This is a .h file, so it just contains the complete class. Yeah, I was looking for set fill, but okay, let me see. Can I jump back? Control T, nope. Set fill is part of the base class, so you just have to make up, or I can jump to the base class. Have a quick look there. The base class of the base class. Yeah, these three even. So I have a set flat create info, set fill index, set characteristic range index, and now we need to add a set set index hint map. Do something about that, I guess. Let me think. I'm thinking about if I can add this to the base class, or that it really has to be in the most derived class. It does use, it kind of lists everything that I want to compile. So, but in general, that's always the vertex and the fragment chainer. Is that limited? I think for now I'm going to add it to the most derived class, and then if in the future I see that I just keep copying code and it's always the same for every application or for every pipeline, I should say, then maybe you can move it to the base class. What namespace are we in? We are in no namespace. Then I need a full thing. I need to set this afterwards, so I cannot use a reference. References must be initialized immediately. Set index hint map. Okay, I need to be able to set it. We are going to set it from the parent task, so that must be a public function. Yeah, I'm going to need more signals now. I need a signal to wake it up in order to compile. I already have do fill and do terminate. So I'm adding it here in the middle, compile. Even though I do the compiling in the derived most derived class, I don't see good reason not to define the condition type bitmap thing for the signal in the base class. That's a new state. Now I need to again to go to the base class because you also need the debug function to print a string of this new condition. So we had a do fill. It's not mentioned here. There it is. To compile. Okay, it seems to be ready now, except that well, maybe not except, because this was registering itself. Registering I cannot pronounce that. Itself with flat create info. God knows why. But in the end, it's just going to be the exact same characteristic child tasks that we already have. So I don't think any registration is necessary. So maybe we can just delete all of this. Right. There's still some leftovers, but maybe they are. Well, this one was called. Oh, we have another one. This one is commented out, but we have another one here. We have to do the exact same thing. Very annoying to do the same thing. I hate that. So this is deleted. And then we get here a new state for the no. Yep, still need these things. That had to be an M, and the shader vert and frag also exists here, talking about code duplication. It really sucks because this one is larger, more code, really like seriously duplicated code now. Not very happy with that. And I still need my window, so I need a copy of that as well. Okay, I need to give a name to this new case. And that becomes compile, obviously. Yeah, same thing. It is create a window, which is a cast of the M owning window, and then we get vertex and fragment shader indexes, and we compile it. This code is definitely the same as in the other one. Could make a virtual function that returns the shader vertex index, the fragment shader index, and then move the rest to the base class, I guess. But I'm gonna leave it along this second. I'm not sure what this means here. Well, it is a debug name for, I think. Yeah, that's still the same. Debug name for where we store stuff. Right. So now all of that is gone. It might even compile. I hope not, but I forgot to add that new state. Compile state. The shader index was not declared. it says, oh, did you mean? Yeah, I guess I did. I'm not using a namespace shader builder here. Probably wanted to do that. It's like the same thing here, right? Just got to add that. Oh, and I did not add that one. Oh. XC tags, and then I can jump to the new one that we added. Let's see how that looked like. It was a pointer right now. It's actually a pointer, so more compile errors ahead. This is from the window class. We're adding that to as a public function. I guess that goes here. Well, public function. I just need to add it as a private member. Now we also need to add a public function that can use to set it. Yeah, this can definitely be moved to the base class. This is just 100% the same, and I'm going to need that map in all cases. So let's immediately move it, I guess. Let's not add this here, but let's add it to the base class. What namespace are we in here? This is pipeline. Okay, and then I need the setter to be put in here. I don't know what that thing is. Set index int map. Already have that in a different class. Kind of funny. But so I want to delete it here, and let's use this one. It should be the same, right? Pretty much, except for the namespace. I'm going to delete this and then move it to the base class. So the window.h is just using it, one for the vertex shader or the fragment shader, and here again, fragment shader. This one I just deleted, I hope, or I guess I did. And that's related to the resource declaration, so it's another one. And then the characteristic range is the base class that now has it, plus the setter. And the pipeline factory is probably using the declaration, the existing one already from the declaration thing. Okay, but yeah, this thing must be protected because you know we are using it in the derived class. Let's make it, so put it there. These are protected. Let's put it even above the terminate, more in the order that it is being used. Let's see if it compiles now. Huh? Yeah. There you can see that yawning is an instinct. You can be surprised that you are yawning. I always do that. Just kidding. Error. No matching function for call to vulkan pipeline shader input data build shader. Well, that's the fact that it is a pointer now. Well, in that case, well, I could dereference the pointer here, but why not change build shader? How often is build shader used? Is it used in a multiple a billion other places? It is used in a billion other places. Why? So, for example, if you look at this one, no, that's a void. That's an initialization. Declarations, initialization, debug output, and this we don't know. A comment. I'm GUI. I don't care about I'm GUI. That has to do whatever I want it to do. This is also not super interesting. So the rest is basically the user code. And the last two we just changed. That's the only weird thing. What is it doing here? It's calling one build shader from another. So we're going to change this set index hint map to a pointer. Or are we? Handle shader resource creation requests. Passes it as a const reference, but that might be the other one then. Update, allocate. I'm not sure, but yeah, well, this one must become a pointer. And this one then too. And this one calls the other one, so that then works. Preprocess just takes. Oh, preprocess. What is preprocess 2? Let's leave that, I guess. Yeah, I don't know. Well, I don't change anything else yet, I guess. Just the build share one. This is the preprocess. This is handle something. Now that set index hint map is seeing places. Yeah, and then it's passed to preprocess too. Could expect that. Okay, I'll just pass it as a pointer to that one then. See how beautiful everything comes together. Now I can remove an ampersand. This was clearly the right thing to do. Well, this compiles, that's officially scary. This is officially scary. It's not working, however, because it's in the pipeline factory I just commented out something. But I always like to see that something does not work, and then finish my code and then see that it works. And then I know that my code is being used, because imagine I just make all these changes from A to Z, and then I run my application and it still does exactly the same thing as before. Then you'll feel like, yeah, is it even using my code? Or is this, say, the old executable that I compiled before? So let's make it crash. It crashes. I'm not really interested in the error, because we know what is wrong. I didn't finish the change. The other one also has to crash. Great, same thing even, same assertion. So let's finish it. Let me think. It's just a pipeline code. I think that was. We have changed all the tests. Edit. I added the state and I moved the code. It's not finished. Nope, but let's just continue with the pipeline. Factory. This was commented out. So what we have to do here is now call that new state in much the same way as we call the fill here, by sending a signal and then wait for it to be finished. Yeah, I really have to look at that, I know. I'm gonna forget, I just keep closing that. Number of running characteristic tasks. Right, so we're going to compile, and then after compiling we are not filled, but we are compiled. Compiled. And then we want to continue with that state. And we are going to wait for compiled instead of filled. This is my index map. Now I need to call just one set. Set index int map. And the current set index int map of this pipeline factory is really an object, although we have to pass a pointer to it. And I'm sending the signal do compile. So all of these things get a signal do compile, and then we wait until we get a signal back that everything is compiled. That's just waiting. And then we continue here after that. Right. Well, okay, but nobody's waiting for this signal, and the other signal doesn't even exist. This one, so more work to do. Let's start with adding that one. Okay, edit them. What else? This compiles. Because I still need a function like this. Very much like this. Yeah, more like this really. So each child task must call this, and then the last one will send a signal to the parent task. What is next? Declaration of this thing. No. Right, so after we are filled, I'm setting this counter back, and then we start all the child tasks again. Yeah, it has already become so complex that it is not really hardly possible to understand what's going on. But that's the fun of tasks. I mean, I was thinking, why would I wait until they're all filled? And only when they're all filled, I start compiling them. Why not just fill one of them and immediately start compiling? Do you see this comment here? Now we have initialized mset index hint map. And that is being initialized by this call, realize pipeline layout, which does incredibly difficult things using that partitioning that I worked on 2 weeks. And this can only be done after all of that has been done, I guess. You have to wait until all the fills are done, and then we can call this, and then we can start compiling them. And all that without blocking threads. Isn't it amazing? Waiting without waiting. They could make a movie about it. Well, anyway, so we set that pointer to the new set index hint map that we just generated, and then we signal that we're ready to compile. Nobody's waiting for this. Still not working. Well, this code looks now done. Yeah, and then we set state to compile, so we will wait until all the compiling is done and we continue with the code below that. That's good enough for me. Sort required, say the resource list. Who wants to know? Let's look at child processes again, which we have 2 of at the moment, fortunately. Oh no, what millimeter? The child task, start with initialize stuff, and then at the end it sets set continuous state fill, and then it runs initialized because we are just initialized ourselves. And the base class is taking care of the filling, and therefore we have no control whatsoever how to get here. Okay, that's annoying. Now this class is derived from characteristic, not characteristic range. It's not a range. Fill is not doing anything. It's probably perfectly okay to continue with compile in this case, but it doesn't exist. I mean, my own. But no, that won't work because we are waiting on the signal. I think we're waiting on the signal for being filled. I think so. Yeah, it's not the right way to do it. Let me see, undo. It's like I need two continuous states now. First I wanted to call the base class characteristic fill, and when that is done I wanted to continue with frame resources count pipeline characteristic compile. However, maybe I can do that like this. I just set my state already. That's kind of dirty, but it works. See if that works. 3 states in one. We're going to run characteristic range initialized. After that is done, it's going to run characteristic, which is the derived class from characteristic range. The characteristic range is the top base class, and then derived from that is characteristic, and derived from that is this class. So we have to tell. Let's swap these two. Anyway, we have to tell the immediate. No, we have to tell the base class of the base class that we want to continue with the state of the base class, and then we also have to tell the base class that after that is being done, we want to continue with this state. Ish, I think. So let's see what this is doing, because this is the one that is being run next. And this is in pipeline. I want to follow initialized. Oops, nope, not working. It calls set state. So that's overriding our set state. Yeah. Okay, we cannot set a state. Anyway, we are here. It set state to check, terminate, wait to fill, or terminate. I guess we'll get the signal do fill, and then it continues here. We're not terminated yet. Then we set the state to continue state. Which is the derived class characteristic fill. That is not possible. At least I need it. But continue here. Sorry, just continue here. Nothing to do. This is not a range. My God. It just calls characteristic range filled. It's totally not doing anything at all. Yeah, it's clumsy. I think the best thing to do is to duplicate the multiplex implementation functionality of characteristic range in the characteristic derived class. And in other words, I really want to set this as the continue state because we're not filling. And now we're running characteristic initialized. Now in order to make sure that we do not make the mistake to call characteristic range initialized, that should not be accessible here. In other words, I'm keeping range, and then that is a mistake. And I must make sure that it doesn't compile. Now this characteristic range is protected. It's a type. It's an enum. Yeah, I guess I gotta redefine it here. Is there not a way to make a single element of an enum and inaccessible? I don't think that's possible. Nah, probably not. Okay, I'm just going to hide it with another one. It's filled. I cannot remember. Initialized. Right, so new state. Yeah, let's just redo everything. So characteristic is just not using the base class state machine anymore. Okay, why are we not why are we not getting here? We are getting here, I think. I did that wrong. We're still going to do a fill. I just have to do nothing. Let's say it's very annoying that I have to do this manually, updating all these states. Maybe we should automate that somehow. It'd be much better if I can just concentrate only on this. Now, of course, I could do that, and then once I'm satisfied, fix the rest. But it's still bothering me. Okay, so anyway, initialized must call this, and then we have to wait for to fill signal. I don't want to do that. I need to do something. I need to set some state. I don't want to have check terminate. It's also not necessary in this case. I can just set filled, and then wait fill. Yeah, does this look good? After we are initialized, we tell it that we are initialized. Wait until it's time to start filling. Then we run this one. If we terminate, we terminate. We call this function because we are just filled. And then wait until it's time to compile or being terminated. And then we continue here, and if we are terminated, we terminate, and otherwise we continue with compiling. That kind of looks good. Yeah, and then characteristic initialized, fill in that one. Need to update this as well. Right, and then I guess now it looks pretty much how the base class should look like, or am I completely crazy? Maybe we should do that after this one works. Otherwise I have to change two places again. Initialize. Continue state, compile, run state initialized, and this then should not compile. Let's try to test it. Owning factories private. Yeah. Invalid use of incomplete clause. Why? Yeah, okay, it's not become too big anyway. Move this. Do we have that file? We have it. What? Oh, this is characteristic range. This is class characteristic. Okay, I guess that worked. And we cannot use this, and it says use that instead. Right, so again, after initialization we run characteristic initialized. And we should continue here. Then, after compiling, and I guess that's here, I should call yeah, well, I know what I want to call, or I could look it up, but you know, in the future everything has been forgotten, and the easiest way would be if I just could do compiled. I just leave the continuous state at that, and I'm running compiled because we just compiled, and then everything should work automatically. Therefore, I'm also going to edit the other one. Okay, and then does it still compile? No, because I don't have a compiled state. Yeah, so we have an initialized and we have a compiled. We do not have a filled because we don't fill anything. Not here anyway. Yeah, I'm getting tired of this as well. The problem is I could add a comma something and then use a something here, but then my switch is going to complain that I'm not using every enum. Just shouldn't be changing this all the time. Okay, so when this is being run, then what do we want to do? We have to call back CharacteristicRange field, just characteristic, no, what it was called, compiled. Just compiled. Also not highlighting, damn it. Yeah, range compiled. That's necessary, so we send a signal that everything is compiled. And this thing is then going to wait for fill again. So we need to do this. Alternating waiting for the compile signal or the fill signal. But when we get the fill signal, where do we want to continue? We want to continue to check if we terminate. We just do this thing. To fill, simply wait for the characteristic fill. It's the same as here, I guess. So as soon as we get the do fill signal, we want to continue in the characteristic fill. You would say swapping these two lines, by the way, is better because then it reads like English. We wait for do fill and then continue at characteristic fill. But my state engine comes with a rule. Every wait must be followed by a break immediately. And that has a reason. So I would swap these two, I get an assert, I think. Yeah, looks okay. Surfing with Rio says, how does this man not make any errors? I make errors continuously. But I write my code in a way that if it compiles, it works. Robust. Not always, but mostly. I mean, it's not 100% true, of course, but let's say that it's very difficult to make a mistake in my code, the way I write it, without getting an assert or a compile error or something other quite obvious. Usually I can just do whatever I want, and then it will point itself out what is wrong, and that is necessary. So I wrote my libraries like that, because if it didn't do that, then I couldn't write programs that are this complex. They are very complex. I cannot have it all in my head. I need code that just points out to me what I did wrong. Otherwise, I'll never get it to work. The idea is that the code is doing something more complex than that I can have in my head or understand, have an overview of. So I don't have an overview, per definition. And therefore you need a certain kind of interface. Now let's have a look if this does something. And it just works. And the UBT, same thing. So now the problem here arises that what I just said seems to be true. I finished coding, it compiled, I did not get a search, therefore it worked. But then there is always that niche case, that tiny little piece that might be left over, where I still have a bug in my program, but I just didn't test it. It didn't get there. And the main elephant in the room, lack of a better expression, is that I never tested characteristic ranges at all. At all. So I have a lot of code that is related to these ranges, and I don't have zero code that tested it. And that's like, I don't know, a year worth of code that was never tested. So that makes it pretty damn dubious. But yeah, I cannot test it until I'm actually ready to make pipeline characteristic ranges. The big thing in this case is obviously that I'm not using the task that is defined in the characteristic range, because I redefined it in the characteristic. That is not a range. And I know for a fact that code is broken. But yeah, if we don't use it. So I'm going to do an attempt to fix that anyway, without being able to test it. And then it should be done with this. Let's go to vulkan pipeline. So this is now new piece of code that I added, specific for characteristic, and it's a virtual function, so it overruled the multiplex implementation of the base class, which I never test. But this comes a lot closer to what I want to have than what I have. Let's find the other one here. This isn't compiling at all. So I'm gonna put the other code in, and then we're going to fix it for compiling ranges, including ranges. I don't understand what you mean, Bochi. What does NGL mean? Okay, is it doing anything special? I don't think it is. And there's a check terminate. Wait, terminate check. Not doing anything special, might as well delete it. I know the IDK, that stands for I don't know. A no cap? No. Try to type English. Basically, I would want to do characteristic fill or terminate now, aka like here, which then would do, check that M terminates, just like here, and then continue with the custom state, which is the actual fill. So there's not really a difference. It's more like terminate or call the continue state. And then after being filled, we come here. That's the same as the compiled, except that we call a different function. Okay, so when we are initialized, we call that function, that's necessary, and then we wait for the fill signal. And then we continue here, continue or terminate, which simply checks if we are terminated, otherwise we continue at the continuous state. And the first time that will be the fill state, which ends with executing the filled, so we get here back here, and we have to call that function. And then I guess also continue or terminate, right? But this time we wait for the do compile signal, and then when the compile signal comes, we check first terminate, and then we continue with compiling. which then follows up with the compiled one, which has to call that function. And then we do again continue or terminate. Okay. So each of these states that end on ed means that we just finished something. Either we just finished initializing, we finished filling, or we finished compiling. In all cases, we must call a specific function on the factory, either initialized, filled, or compiled. And then in all cases, we set the state to continue or terminate. And after compiling, we wait for the fill signal. After filling, we wait for the compile signal. And after initializing, we also wait for the fill signal. And then in all cases, we continue here, which we first check terminate, and then we just continue with whatever the user said. Now, what can go wrong here, I think, is that the user is not calling the right thing at the right moment. So I could add some debug code that checks that this is being that we get here alternating. After initialize, we must get here first, and then after filled, we must get there first, and then we must go there, etc. So let's add some debug variable, that is, let's say, the expected state. The expected state of those three, ignoring this one. Characteristic range. Yeah, the first state is of course this one. It's the end state of the base class. I don't think I have the initialized defined yet here. So I can just do it like this. To one. So the next state after compiling is again filled, right? Okay, yeah, I can't test it right now, but it looks okay because of the symmetry. Everything is almost the same, like I just explained, what they call and what they do. And yeah, it's just has to work. I could even add a debug output if this fails. The continuous state was still set. So if the continued state did not end with set the run state equals the expected state, then that was wrong. So I could make this can I do a core initially? Conditionally, I mean. I don't think actually I cannot. I can do conditional output, but not conditional fatal. Nah, let's just do it like this. Right. So I can add it as a comment. Right. Gotta be kidding me. Oh, okay. No, man, they just like my soothing voice. It's relaxing. If there's anyone here for the C++, please tell me. That would be interesting. No, I'm just kidding. But so many people tell me that they don't understand what I'm doing. It compiles UBT and it crashes. It crashes. Why? Search and run state, blah 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 blah. Let's just look at the comment. Oh, but characteristic range multiplex implementation, that should never even be called. And suddenly it is. No, that should not have been called. Yeah, basically the other one also is not reached. Unreached, never reached here. I think that's the reason that we get there, but we should never get there in the first place. Never reached. So now if I run it again, we should crash there. But why do we get there? we get here? Why? Missing break. I don't see a missing break. Oh, of course. I'm using break instead of return. Yeah, that was just confusion of my part. The moment I started to rewrite it. We definitely reach that point. Same in the other one. I'm just using break, so it just should return from the function. If you have a base class task, I should use return instead of break, and then call the base class implementation at the end, in case we try to switch on something that is a part of the base class. Well, it's just I mean, it works again, I guess. Because now we don't call that base class thing anymore anyway. Let's commit what I did. So this lambda now has become a state in the state machine, or in the task. I used to call it the state machine, but now I'm calling it a task. The other one as well. Hello, kind HPD. I think we can just commit this. Okay, then the fix me. All of this was just to fix one fix me. And well, this one. So before this was a monolithic function, and then somewhere in the middle of the function we do this. And I was like, why are we doing this here? Because it really has to be called only once. And it was in the middle of a function. So we could not leave here or something, or wait. You see, it has nothing to do with the pipeline here. It is a window function. Oh, it does. We passed this pointer. It's never as easy as you would like. I think one of the reasons is that you cannot call this earlier. We need to do it after preprocessing, probably. Everything must be done in a certain order. Might be that this needs to be done before that, and that needs to be done after that, and all whatnot. I'm not sure though. I have no idea actually. Well, we only want to do it once. Let's see what it does. Create vertex buffers. It's not a virtual function. Yeah. We are passing the owner of the pipeline. And the owner of the pipeline would be a characteristic range. So we can access the shader input data object, and then from that the vertex shader input sets. And then we have to do stuff with that. And create and run yet another task. Also in the low priority queue. Starting to use tasks pretty heavy. That's a good thing. Lots of parallelism. Okay, so this creates vertex buffers and uploads them to the GPU. Yeah, I need music. It's too silent. Let me think about this. What is going on here? Vulkan, that is an API to control your GPU. So Vulkan is the successor of OpenGL. Still cannot really wrap my head around this. If you just type Vulkan, then you probably will not find it. But you type Vulkan C++, and you'll probably already find it. If you type Vulkan Engine, you probably also will find it. The related site is www.vulkan.org. Though I find it a not very clear website, lots of nice pictures, but I don't know. The point is, of course, what happens if I want to use the same vertex buffer for different pipelines, different pipeline factories even. Like, I'm creating one now, and then if that same function, same pipeline factory would somehow get here again, and then I could halt here. And just checking that it is single threaded is not enough. Now it is now per definition single threaded, by the way, because it is a task. Every task is only executed by one thread at a time. Well, one thread at a time. Okay, this tests that this line is never executed by a different thread. The first thread sets the SID, and then after that only that same thread may execute it. Since this is part of a thread, you have no idea which thread is executing it. Sorry, part of a task. You have no idea which thread is executing it. So this is fuzzy and might fail only if this is executed more than once. Thank you, Logan. Yeah, I wrote a lot of code. Yeah, just like 20 years of work. Not all repositories are mine, but when in doubt, it's probably my repository. Well, now we're talking about my repositories, and we have a lot of beginning C++ people here who are asking, what shall I work on? I have no ideas. And I was thinking, why don't those people not pick up one of my unfinished projects? Which is called Probably somewhere at the bottom because I did not work on it for a long time. Is this one private? So I just saw it here. Solar panels. It's private. You cannot see it. I guess I made it private because it contains the exact location of my house. Oops. I wrote. I had to decide how many solar panels I wanted on my roof. So to show what kind of person I am, I wrote a huge program that simulates everything, the Earth rotating around the Sun, and yeah, the angle of my roof, the position of my house, the way it points, so until I had in 3D the exact angle at every time, at any time, that the sun would be shining on my solar panels. And I didn't stop there. I investigated aging of solar panels. I found research papers about how solar panels degrade as a function of angle of incidence and time and dirt. So if you have more dirt on your solar panel, then they become less efficient, of course, but they become even less efficient when the sun is shining under an angle on it, because they become more reflective. And so on and so on. I put everything in it. So that was the only way I could make the decision. And I just ran a simulation for the next 25 years because I have to pay for them. I hire them. And then I chose the number of solar panels that with my electricity usage gives... I'm just completely crazy. Completely crazy. I think sometimes I think, I like I said yesterday or 2 days ago, that I have been diagnosed with some form of autism, and then sometimes I doubt that. But if then I see myself do this, waste my time with writing a program like that just to make a decision of 6 or 9 or 12 solar panels, and then suddenly I have to admit, yes, I'm completely autistic. Here's another private one, by the way. If you have crypto, I don't know, anyone has crypto, you have to make up 24 words that then are your secret password, say. So that's all your crypto can be stolen if someone has that. But if you lose your hardware wallet or it gets stolen or whatever, then you lose your money unless you lose your crypto unless you have those 24 words. So you should write them down. But yeah, if you write them down, then people talk about losing it because your house burns down. So you have to store the piece of paper in several places, like with a friend or with a family. And so if one house burns down, you still have the other piece of paper. But then I was thinking, if I store a piece of paper all over the place, someone might find it, right? I mean, I did put a piece of paper in my parents' house, but that is being cleaned by someone. They might find that. So I did not want to write the 24 words on it. But on the other hand, if you read about the security of this, it is not secure to store these words on your PC, because then if anyone breaks into your PC, they have those words and they have your money. So you can never type it in your PC. I mean, you have to assume someone did already hack you and they are keylogging your keyboard. I mean, if it's about a lot of money, right? So what I did was, I really never ever type those things on my keyboard because I have a hardware wallet. That's the whole idea of a hardware wallet. I just press buttons on a USB device. So my PC, if anyone has hacked my PC and they can lock my keyboard, then they still won't know. They can still never access the crypto. So, but anyway, I wrote this, and this allows me to randomly swap all the 24 words for other 24 words using the computer without typing in my words. And it's also written in a way that maximum paranoia. It's echt everything that is stored in RAM is stored in temporary RAM. It's stored encrypted. It's overridden as fast as possible, and it is. Even if you make several copies of my memory while I'm doing this, you're still not going to find anything. So anyone has a crypto, I can give the link. Even it's private, but actually the link is down here already. You just can type in BIP39 converter, and then you can find it. Right, I was looking for why do I have the feeling that it's at the bottom? It is. The very last one. Yeah, this is something I ever started. Description, it's a small C++ library to play with finite fields. I think it's a really cute little thing that you can play with. You just have to learn a little bit about finite fields, of course, but it's not that hard. You might even be able to learn it from the code itself. I'm not sure how much I wrote. I have a Galois field element.cc. Guess I put it in include headers. So it gives you a head start with some classes. Yeah, it doesn't look like it has much documentation. But I think it would be a really interesting thing to look at and work on and then extend and make work. Yeah, I'm not going to say that you need to know Galois theory, because you definitely do not. But you need to understand finite fields. Characteristic 2 would be enough. I didn't even implement anything else yet. The characteristic is assumed to be 2 here. I have very few viewers, so maybe it's a bit of a waste of time to go into it, to explain what it is. I'll try to explain it super fast. So everyone knows what the Z2, right? That is a finite field with 2 elements, 0 and 1. You only have 0 and 1, but it is a field. A field means that you have all the normal operations on 2 pairs of numbers. Addition, subtraction, multiplication, division, etc. Although subtraction and division really are just derivable from the main 2, addition and multiplication. And the only pairs we can make is 0, 0, 0, 1. Maybe it makes a difference if we swap them. It doesn't. But okay, these are two numbers from this field. You have only two possibilities. And we can make these pairs, 4 pairs. Obviously, right? If we then add them up, 0 plus 0 is 0. Nobody will be surprised by that. 0 plus 1 is a 1, and 1 plus 0 is also 1. And 1 plus 1, yeah, 2 does not exist. So that's 0 again. That's actually Z2. You just add them up, you get 2, and then you subtract 2 until you get less than 2. So 2 minus 2 is 0. So it wraps around. And if you multiply them, well, 0 times 0 is 0, 0 times whatever is 0, and 1 times 1 is 1. So this is the multiplication table, and this is the addition table. As you can see, this is also exclusive OR, and this is AND. So the computer is going to be very happy calculating with this. Now, if I have defined x plus y z, then you will understand that x minus y is also defined. Namely, that's in this case equal to x plus y. Y, well, you just add 2y. So we have x minus y plus 2y, which is obviously x plus y. And we can do this because 2, that's 1 plus 1. Okay, 2, we don't have a 2. I'll just add y twice. There. So you have x minus y plus y, that drops out, and then we are left with x plus y. And adding y twice doesn't do anything, because 1y plus 1y is 0y. It's a plus here. So this whole thing is optional, and therefore x minus y equals x plus y. I use that. And well, division, something the same. Now we're going to do something interesting. Suppose we have a t, and we don't know what t is. It's some incredibly complex number. You cannot write it down. It's like pages and pages of square roots. Maybe not even, you cannot even write it down. I don't know. The only thing that we know is that it's a root of some kind of polynomial, a primitive polynomial, but I don't know. Let's make up a polynomial and claim that it is primitive. Would have to look up which order 7 polynomial is primitive. Let's say this one. So t is defined by the fact that t to the power 7 plus t to the power 3 plus 1 equals 0. And now we're going with using that t, just pick one of the 7 roots. We're going to use that to write polynomials with coefficients. Let's say I call it C6 times t to the power 6. It's to the power, right? It's not exclusive OR. Plus C5 times t to the power 5 plus C4 times t to the power 4. Yes, I'm going to write them all. T to the power of 3 plus C2 times t to the power 2 plus C1 times t to the power 1 plus C0. This is now a new thing, and all the C's are element of Z2. So they are 0 or 1. It is Z2. So it's normally write it like a different kind of Z and in index too, but I can't do that here. So each of these values are 0 or 1. This is 0 or 1. If it is 0, you can just leave the whole term away, and if it is 1, you can just leave it away as well, but still keep the t. For example, let's say C6 is a 1, then we would have the polynomial t to the power 6. And let's say C5 is a 0, and C4 is a 0, and C3 is a 1. Keep one of the pluses. Say C2 is a 1, so you have t to the power 2, and then C1 and C0 are 0 again. Now this would be a polynomial, one of the polynomials. How many polynomials do we have? Well, that's easy. Each of these are 0 or 1, and we have 7 of them. 1, 2, 3, 7. So the total number of polynomials that we have is 2 to the power 7, which is 128. Of course it's 128. Okay. There are no more polynomials. This is the full number. Oh, I hear you say, but what about a polynomial like t to the power 7? We could add C7 times t to the power 7 in front of it, and then we have 2 to the power 8 possibilities. Assuming C7 is 1, it would make a difference. But no, if you add t to the power 7 to any of these 128 polynomials, then I would have to note that this t to the power 7 equals t to the power 3 plus 1. And yes, it is minus t to the power 3 minus 1, because you know you subtract t to the power 3 from here and you subtract 1 from here, so you get negative. But plus 1 equals minus 1, as we saw here. Or here, minus y equals plus y, minus 1 equals plus 1. If this is 1 and this is 1, because they're both, if they're 0 on both sides, then the minus doesn't matter. If they're both 1, then 1 plus 1 equals 0. Right? I've shown that here. 1 plus 1 is 0. So that still works, and therefore t to the power 7 can be written as t to the power 3 plus 1. And now we can do the modulo 2 thing on the argument. So if you add t to the power 7 to this polynomial, you get t to the power 3 must be toggled. So this one is plus or minus 1. I mean, if you really want to toggle it, you would do minus that, but since plus and minus is the same, I might as well write it like that. Plus 1. And then the 1 must be shifted, so I get this plus 1. So adding t to the power 7 or any higher power for that matter is still one of these polynomials, because you just flip 2 bits in this case and that's it. So this is really the limit. There is you only have 128 possible polynomials. And it's a field. We now have a field of 128 elements. Here we had a field of 2 elements, now we have one of 128 elements. How is that? Well, if you have 2 of these polynomials and you add them up, then you can just add all the coefficients up. Let's say I have another polynomial where we have coefficients d, and we add that up. Then you get C6 plus D6, which is again, you add them up, Z modulo 2. So it's again 0 or 1, you just add them up like this, times T6, etc. So totally, again, one of those 128 polynomials. Yep. And you can multiply them. Because we know that if you multiply, let's say, just multiply them the normal way. You do the first term times the first term here, and this term times that term, plus this term times that term, and so every pair that you can make, you multiply. Multiplying is done according to this table for the argument, and the t, of course, is just adding the exponent. So say at some point you want to multiply that with that one somewhere in the large sum that you get, then you would get C4 times D2 times t to the power 4 times t to the power. Well, let me do it like this. We have D4 and we want to multiply that with D2 times t to the power 2. So that is then C4 times d to the power 2 times t to the power 4 plus 2, which is again an element of Z2. Multiplication is just again 0 or 1. And this is then t to the power 6. And if you get something, let me just write it out full. If you get a power that is higher than 6, and you just replace all the t to the power 7s again with t to the power 3 plus 1. You can always reduce the highest power to one of 6 or less. So also multiplication, two elements can be multiplied, and the result is again one of the 128 that you have. So therefore this polynomial is a field, and you can rather easily make a computer and do those calculations, because you can represent each polynomial simply with a bit set. Let's say I just C6 is this, and then you do C5, C4, C3. In total we have 8 of these, 7 I mean. So this is one of these polynomials. And you can just represent that with a bit word by the computer. And then if you have another polynomial, say we have this polynomial, adding them means doing the exclusive OR. So if I add these two, we get 1, 1, 1, the exclusive OR, so that becomes 0, 1, 0. That's a polynomial of adding these two polynomials. Multiplying them is a little bit more advanced, but doable. Fits on one page, I bet, that code. And well, maybe I did make a start here. Did I close the window? This is a polynomial over Z2, which I just explained, and it is simply stored as a bit set. And I defined the plus operator and the multiplication, subtraction, and even division. And the GCD, the greatest common divisor algorithm, can be applied to it. So here you have the multiplication already. It does not use the reduction polynomial. So this is just assuming that the t to the power 7 and t to the power 8, etc. are not limited. They are not reduced. It just calculates, I think, the result is if you multiply them without a limit, without a t as a root or of some polynomial. Since it's a field, you can implement all kinds of other things, like modulo one polynomial with another one, and implementing the greatest common divisor using the polynomials. It's really fun. I mean, the GCD is basically implemented in terms of a modulo. As you can see, one is larger than the other. We swap them, and then you just do one modulo the other one until one is 0. Super simple algorithm. So we still needed to do the modulo then, and then well, here we have the implementation of modulo of the polynomials. Also pretty simple. And I guess that the Galois field really implements the reduction polynomial. I guess I called it modulo here. So we have a polynomial that is used as a modulo. That is then the polynomial that we set to 0. So the t to the power 7 plus t to the power 3 plus 1 that we had equals 0. That is then also a polynomial. And I already implemented the modulo as you just saw. So easy thing to multiply two Galois field things. Then you just multiply them normally and then apply the modulo polynomial. Kind of looking for the multiplication here. I don't see it yet, so probably have to pick it up from there. Okay, well, yeah, I talked about that very long now, but hopefully someone is interested in maybe play with this. Something I don't have time with anymore, but it's super interesting to play with finished fields. Of course, they're related to cryptography, I mean. Yeah, okay. Did I just send commit an if 0? Or is this an extremely old window? I think it's very old. Yeah, this is from yesterday. Right, yeah, my vertex buffers. I wonder where I have to wait for that. What happens if I just don't generate them at all? I mean, then I cannot draw. But then where exactly does it go wrong? I think it's pretty clear that that point is the earliest point where I can do it. But before which point do they need to be finished? That would be the point where it goes wrong, I guess, if I don't generate them. So maybe you can find it that way. So what happens if I do not do this? Thank God, a core dump. It's easier than validation errors or just a black screen. Segmentation faults, not an assert. I don't think so, no. Yeah, there's more black screen, but we also have our seg fault. I'm guessing that we get a seg fault because my vertex buffers is empty. And I'm accessing it. It says a length of 0. And I'm accessing element 0 and 1. Right, well that then means that we have to do it before we start drawing, because this is drawing. No, it's not that simple, I'm afraid. Because there's another fix me here. Fix me. This is a hack. What we really need is a vector with a render proxy objects or some other solution. The idea of the render proxy object would be that I just made up a name, so don't look at the name, but the idea is that those objects are then something that represents something that must be drawn. If you ask me, that is a pipeline. So maybe we should call it a pipeline instead of a render proxy. I mean, if you have a pipeline and you want to use it to draw something, or maybe also not. Could make pipelines in advance and then sometimes use them and sometimes not use them. But at the very least, the pipeline must be complete, finished, before you can use it to draw something. In this case, we have a pipeline that is using vertex buffers. It just has shaders in it that use the vertex buffer. So I would not call the pipeline complete, usable as it were, when my vertex buffers are not defined. So I'm gonna track back where this comes from. The vertex buffers here are a container type, a reference to a read locked vertex buffers, and the read lock happens here. This is a thread safe thing that wraps some mutex together with the actual vertex buffers. So we just go to the M vertex buffers, and the type is this wrapped vertex buffer container type. There's a vector of vulkan memory buffer objects. Okay, so before we draw, this must be filled. You must be done with that. And the way it works at the moment is that we start drawing as soon as the graphics pipeline has a handle. So as long as this fix me is not fixed, I would say we have to do this before we set the graphics pipeline handle. Otherwise, I could say I don't care how long it takes, we just do it, and then by the time and this has a value, some signal travels to some object like a render proxy, which then inserts itself into the render loop and starts showing itself. And not necessarily before or after having a handle. But for the time being, let's call that a limit. As soon as my graphics pipeline handle is being set, I want my vertex buffers to be initialized. So I have to use, you have to look for both this one and that one. See whether they're being changed. And the other one was M vertex buffers. IMQ has its own pipeline, so we can ignore that. And then the application has a pipeline. And then our application has a pipeline. I think this is just a handle. So I think this is the one that keeps the pipeline alive or something like that. I don't know anymore. We create a pipeline here, but it doesn't have a handle yet. And then we get the handle in here. I don't know. Here it is just being used. Just drawing. Drawing. This is the test. Yeah, my guess is that this thing would do it. Yeah, this passes a non-const reference. So that would allow us to change the handle at some point. So I'm going to assume that it happens by passing it to pipeline out. Pipeline out is passed to the creation of the pipeline factory. Second argument. Which is stored in M pipeline out. And we have a set pipeline here. I really have to look at this pipeline object class. It is the moment that this handle is being set. I bet handle. Here it is being set in the constructor. Apparently. Right. Well, one way or the other, this should be it. Have new pipeline. Set pipeline. I guess before this point it has to happen. So who's calling have new pipeline? That's this thing here. have new pipeline is called yeah, this is something I invented. It does not have call by the consumer, or what that is. It's a derived class. Okay. Task or task DQ. Okay, this is the one then. So at some point the producer, whoever that is, calls have new datum, which is then picked up by a call to the consumer by a call to flush new data, which we just saw. At which point it happens. So I'm gonna have a look at what we're calling that. And that should be the pipeline factory, right? Yep, pretty much. So here we have a call that we have a new pipeline. Yeah, so here the pipeline is created, and then we move it to the task-to-task DQ. So another task can do stuff with it. So we want to do our thing before we get here, I think. Which is in the state pipeline factory update missing descriptor sets. Now here's another wait. And pipeline layout creation. And here the real creation starts. So we could insert a new state here. And then wait here until the vertex buffers are uploaded. Lawyers. Well, listening to, but also you when you sleep. I mean, you have your eyes closed. I hope. I think if you fall asleep, then also your hearing turns off, right? I can usually observe that just before I wake up. You hear your own hearing. You hear your own hearing being turned on. Soft sounds do not get through, I think. Okay, let's try to remember this. And the pipeline creation. Okay, that seems like a reasonable point. In the pipeline factory.cxx. The vertex buffers. It's still some kind of race condition, isn't it? Because I commented out the call to this function and then it crashed. But the function creates another task, which can just be as slow as it wants. Probably unrelated. If that task is very slow, however, then I have the feeling that we get validation errors or even TPU crash, because it's going to access the shader is going to access a vertex buffer that doesn't exist yet. It is a race condition. Might even need a barrier somewhere, somehow. Didn't look into barriers at all yet. So I fill my vertex buffers like this, so I cannot crash anymore on accessing it. But I'm not doing this part. I'm just simply not running it. What happens then? No, that would show a race condition with that task. This goes wrong. And of course it goes wrong, because I don't have anything to draw. Or nothing goes wrong. That's interesting. Just have nothing to draw. Maybe that is exactly the delay that we normally see. That this just takes seconds. Okay, so let's run it, but let's add a delay. Ah, see, we have a barrier here. We do have a barrier. That's interesting. I have no idea how that works. But let's add a delay to copy data to buffer. Or is that a bit too much? Also using that for IMG. Okay, so this thing runs here. I'm just gonna add a sleep. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. And again. 4, 5, 6, 7, 8, 9, 10. And again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it took a while before IMView appeared, and then it took a while before you saw the rectangle appear before the random distribution. That was very interesting. But nothing crashes, nothing goes wrong. It just takes longer. Robustness, gotta love it. The kind of thing you won't see in other programs, you know, written by companies with deadlines. Nobody knows where I added my sleep. Okay, so that last task is not a problem apparently, but we do need to create our vector before we start drawing. I'm going to turn on my lights. Be right back. Code is, it is in the here, Linux viewer. And it's on GitHub. It's in the description, the link to GitHub. Yeah, welcome back, Nikon and Bear. Didn't see you yet. Sleepy. I did get out of bed very early today because I had to go shopping. I got out of bed at 10:30. Amazing. What shall we do next? Create a vertex buffers. This is now being done inside initialize. Okay, that's but why can it only be done here? Must be because of this? No. Oh, yes, that's the reason. Very simple. It's because we need to do that. Add vertex input binding first. So in the initialized state, this is being called. And only after we added those two, we can call this. So now the question is, what if we come here for multiple characteristics? And both characteristics use this heavy rectangle thing. Yeah. Let me see. Mm. Yeah. So this shader is reading from the buffers. So vertex data is a vertex buffer that has data per vertex, and instance data is a buffer that has per instance data. And the way that the shader knows where to look is because of these generated locations. But that means, I think, only that we need to bind them. We do that while recording the command buffer. So it's really pretty independent. I would say it's like totally independent of the pipeline. Per vertex, well, this is being called, main is being called once for every vertex. Massively in parallel, of course, but this is executed for one given vertex. Yeah, what to do here? So I think that the point where we crashed, the binding happens. And the only thing that I really need at that point is to know what my shader expects as the location. Let's have a look at that point again. This line. Yeah, I don't know. I don't know anymore. The location here is not visible. We're just binding them. How? Maybe location is implicit. First one is always location 0, and then the rest depends on the size or something. Or all the information is in these descriptor sets. JR12395 says location is based on the order in which you bind. Yeah, well, that's what I thought just a second ago, but so the order would be this one. This this is the first one, and that's the second one, right? And this is location 0 then, and then this is location 3. Why? Because this is has a size. Or it's related to, I don't know. I forgot. I already implemented it, so I just should know, but I forget everything. I get it. I guess it's described in the descriptor sets. All the code? Or just the vulkan code? I'll do this, I think. And the vulkan code, which I worked on basically the last 2 years then. It's only 40,000. I don't think I wrote all of this. S is including external. Okay, I did write libcwd, but you really want to count that? Oh, it's even including vulkan API. Yeah, no, I don't want to do that. I think it should filter out external and filter out /user. It's going to be much less. How to do that? Can I just do this? That didn't work. I just think that you have to do something like this. Right. And then you have to filter out external. Minus V. Yep. So this is all the code that belongs to this project that I wrote. Dramatically less. Yeah, dramatically less. 100,000 lines. Yeah, I'm tired. I'm not really seeing it anymore at the moment. I think that the window has objects. Each object might represent a vertex buffer that I want to upload to the GPU. If multiple pipelines use the same object, then each will get an add vertex buffer of the same object, and then they should be using the same vertex buffer. It should only be uploaded once. Where using the same means that they will be bound to the same buffer, the same handle, and of course then you have the problem that if you turn the camera and 10 seconds long that buffer is not being used, then why would I keep it in the GPU? So I think I have to also need a way to not have it on the GPU and then maybe upload it later again as soon as it's needed again, kind of dynamically. But I guess that's something for later, otherwise I make it too difficult. So each pipeline gets a vertex buffer added as an object, and I should just keep track of duplicates and then have them use the same handle. I don't know how to do that. I think I have to write a test application that actually has this problem, uploading the same buffer twice, and then I can write a code to avoid that. Yeah, I'm gonna stop for now. Can you show this engine run? Dude, I just have 2 small test applications. It's the only thing I have. It's doing nothing. Except that it doesn't crash and you can resize it. Limits to 60 frames per second. This test application I can change a lot of things, like heavy usage of CPU in the middle, the number of frame resource counts, set to 2 should be excellent, set it to 1, nothing really changes. But okay, let's make this scene complexity so difficult that it only can draw 6 frames per second now. Now it makes a difference, does it? Minuscule, if at all. No, 6.2-ish. I set it to 1. Okay, that is 6.0. What do you do it for? Okay, and I set it to 5. Oh, 8. No. Back to 6.2. No. In general, it doesn't make any difference, it seems. It changes swap chain image count. Maybe it was too limited by the CPU. So we have no CPU at all, just the graphics. It's a really downer to see that nothing makes any difference. But hey. Yeah, there's also a tool that where you can see the graph, the timings of everything. Also very confusing. But I already spent a lot of time on that. And then just gave up on improving it. Driver does what it wants. What can I say? And the other test application is doing this. So 2 pipelines, and these are the frame resources that I have. So it's artificially changing the coordinate of one of the triangles for each frame resource. So you can see the frame resources. But here it is set to 10 frame resources, I think. Something ridiculous like that. And I cannot change it. You can just change the top position and the left bottom. So the whole test was written just to see that I can write uniform buffer to a uniform buffer, and I read that in the GPU. So in order to see that I am reading the right value in the GPU, I'm drawing it and then use what I read from the uniform buffer as a coordinate of the triangle. Hence it is called uniform buffer test. And then I use it also to make sure that I can automate generating the descriptor sets. I can now make structures of structures and arrays and everything you want, and automatically does all the alignment and the sizes and stuff, and then generates the declaration, the GLSL declarations. It figures out which scriptor sets to use. Everything is automated, which is of course not something that you see here. This could be a 2-week tutorial instead of 2 years. Dinner. Okay, I'm going to eat an ice cream because it's dinner time. I'll be back later. I have no idea how much lines the driver has.